All right, so now we're going to look at these graphs, which are a little different. So we're going to sketch each of these graphs by hand. E to the x, e to the negative x plus 1, and x squared minus 1 over x squared minus 4. Now, you ought to be able to graph all three of those by hand. So start with that. And if you need to, look at the calculator or Desmos, whatever you use for help. Okay, now, once you graph those, I want you to think of what each limit should be. So I've got p, well, limit as x approaches in. So this is the first time I've written that. The limit as x approaches infinity of p of x. What do you think it is? The limit as x approaches negative infinity of q of x. What do you think it is? And then in the limit as x approaches infinity, limit as x approaches negative infinity of r of x. What do you think they are? So take a moment, take a pause, sketch these graphs, and tell me what you think those limits should be. All right, now hopefully you are back. And so let's look at what those graphs are. So first of all, we're looking at p of x. So I really hope that everybody knows that the graph of e to the x looks like this. All right, and what do you think that as the x is approaching infinity, so the x's are going out to infinity, what value are the y's approaching? Well, the y's are getting closer and closer to 0, so we say that the, I put my graph where I should be putting my answer. Limit as x approaches infinity of p of x equals 0, because the y coordinates are going to 0 as the x goes to infinity. All right, next one, a little bit trickier to graph. But knowing the e to the x graph, you can graph it using transformations. All right, so you know that e to the negative x looks like this. All right, and the plus 1 is just going to shift that graph up 1. All right, so that graph is going to have a y-intercept at 2 because e to the x has y-intercept at 1. And it's going to have a horizontal asymptote at 1 because this graph has a horizontal asymptote at 0. So here's what that graph looks like. All right, so what do you think the limit as x approaches negative infinity of this function is? So as the x's are going out toward negative infinity, going this way, all right, what are the y-coordinates approaching? Well, the y-coordinates are getting closer and closer to 1. So that equals 1. All right. Now, how about r of x? That one's a little bit trickier to graph, but let's see, we can probably figure out pretty quickly that looking at the numerator, I have x-intercepts at 1 and negative 1. So 1 and negative 1, and I have I have vertical asymptotes at 2 and negative 2. So here's negative 2. Actually, I guess that's negative and that's positive. Here's negative 2. Here's positive 2. All right, I have a y-intercept. You get the y-intercept by just covering up the x's. I got negative 1 over negative 4. So the only important thing about that is that it's positive 1/4. All right, all my, so the only important thing about it was positive. All my asymptotes and intercepts are odd multiplicity, because I factored this as x plus 1, x minus 1, x plus 2, x minus 2. Each of those binomials is raised to the first power. That means we're going to pass through this intercept, and we have to approach that asymptote. We're going to pass through this intercept, have to approach the asymptote. We're going to reverse. We should think about where the horizontal asymptote is going to be. Highest degrees are equal, so it's going to be 1 over 1. So that means that I have a horizontal asymptote at 1. And because this is these are both odd vertical asymptotes, the graph has to look like that. All right, so that's what that looks like. All right, nice and easy to graph. Didn't take very long at all. Okay, so what's the limit as x approaches positive infinity? So as the x's approach positive infinity, what are the y's approaching? Well, they're getting closer and closer to this horizontal asymptote, which is 1. And what about when x approaches negative infinity? So we're going off this way to negative infinity. As the x's approach negative infinity, what are the y values approaching? They're approaching 1 again. All right. So if you've got the idea that the limit as x approaches infinity is a horizontal asymptote, you are right. All right, so anytime I take a limit as x approaches either positive or negative infinity, I'm looking at a horizontal asymptote. If you look at any limit as x approaches as the limit point is a real number, and the limit value is infinity, then you're looking at a vertical asymptote. And so in particular, if you're looking at, for example, this one, h of x, we could say about h of x that the limit as x approaches 2 from the left of h of x is equal to negative infinity, and the limit as x approaches 2 from the right of h of x, as we approach from the right, the y values approach positive infinity. So when we see a limit from the left or a limit from the right that's equal to infinity, so the limit value is infinity, even though the limit itself of h did not exist, but it didn't exist because the left and right values were both infinity. So anytime I'm looking at either a left or right limit at a point and the limit value is infinity, or if I'm looking at a limit as x approaches a point and the value is infinity. In either case, I'm looking at vertical asymptotes. So these are all vertical asymptotes. When the limit as x approaches a point, the limit value is infinity. The limit point is a real number, limit value is infinity, vertical asymptote. Now, when I'm looking at a limit as x approaches infinity, so we say the limit point is infinity, then I'm looking at a horizontal asymptote. So limit point is infinity, and the limit value is a real number, then I'm looking at a horizontal asymptote. So that means that all the things that we know about horizontal asymptotes are also telling us about limits as x approaches infinity, so that I would be able to look at this right away and say, oh, since this graph, from what I know from pre-calculus, this graph has a horizontal asymptote at y equals 1, then that right away tells me, without even looking at the graph, I know that the limit as x approaches infinity of r of x equals 1, and the limit as x approaches negative infinity of r of x equals 1, because that's the horizontal asymptote. All right, so especially if you forgot how to find horizontal asymptotes, that's our next video. We're going to talk about horizontal asymptotes, the rules that govern them, and how we compare limits where the limit value is infinity and limits where the limit point is infinity.